Jai Gurudev to all of you. Today we discuss the chapter complex number. First of all, the meaning of iota. Iota represented by the I, that the meaning is root over minus 1. For example, we know that root 4 is 2, under root 9 is 3, but we discuss about the value of minus 16, root over minus 16. So we can write them 16 into minus 1. The meaning of root 16 is 4 and we can separate the root minus 1. We can't solve that value root minus 1, therefore it to be called a iota represented by I. So that is the answer is 4 into I. Now iota, the meaning of iota is root over minus 1 represented by iota. The number having an iota, I is called the imaginary number. It's called an imaginary number. Like that root over minus 4 into root over minus 9. So that we can write as root 4 into root minus 1, root 9 into root minus 1. Root 4 is 2. The meaning of root minus 1 is iota. Root 9 is 3. Root minus 1 is iota. 2 3 is 6. Iota is square. And the value of iota square is minus 1. Later on we discuss why the value of iota square is minus 1. So the final answer is minus 6. Now we discuss about the values of various values of iota. Iota is root over minus 1. Now we can take I square. So squaring both these sides. So that is the iota square. That is the squaring of root over minus 1 whole square. Square and square root are cancelled. So we get minus 1. So final value of iota square is minus 1. That's why we put here the I square is minus 1. Now the value of iota cube. Iota cube is I square into I. We know that I square is minus 1. So minus 1 into I, that is the minus I. Next the value is iota 4. Iota 4 write as I square into I square. The value of I square is minus 1. Again is I square is minus 1. That is the plus 1. So you can remember it, these four values. Iota is root minus 1. Iota square is minus 1. Iota cube is minus I. And iota 4 is plus 1. All these values can be converted in that term. So various example of that kind of problem. First example is iota to the power 19. So whatever the power we can separate with the power 4, because the positive value of iota 4, least positive value of iota 4 is plus 1. That's why we can break with the power 4. So we can divide by 4. So 4 4s are 16. 16 plus 3 is 19. So 19 write as 4 into 4 plus 3. Now using the formula we can break it. Iota 4 whole 4 into iota cube. I repeat again, we can break with that formula. Iota 4 whole 4 into iota cube. Iota 4 is 1 to the power 4 into iota cube. Iota cube is minus 1 minus I. So final answer is minus I. Next example is that iota to the power minus 19. First we make that as a positive power. That's why we can make it 1 upon iota to the power 19. Iota to the power 19 again write as iota 4 into 4 plus 3. Separate the power iota 4 whole 4 into I cube. Iota 4 is 1 and iota cube is minus I. So we get 1 to the power 4 into minus I. Finally we get it 1 upon minus 1 upon I. So I is an imaginary number, cannot write in a denominator format. That's why we can make multiplication iota both numerator and denominator. We are getting iota into 1 is I and I square. That is minus I upon I square. I square is minus 1. So that's why we are getting I upon 1 minus minus cancel. We get final answer is plus I. So that these are the problem we are getting the iota terms, answer in iota terms. Either we can get a real number. Next example, iota to the power 25. We can write that iota 4 into 6 plus 1. That's why we write it iota 4 whole 6 into iota to the power 1. Separate with the formula. That is the value is 1. 1 to the power 6 is 1. 1 into I is I. So final answer is I. That is the answer. Next example, minus iota to the power minus 37. First we make that power is positive. We can write 1 upon minus iota to the power 37. Okay, now minus is odd time, that's why we can write that 1 upon minus iota whole 37. 37 power divided by the 4, so we get minus 1 upon iota to the power 4, 9 the 36 plus 137. We are getting that by separating it 1 upon iota minus 1 upon iota to the power 4 whole 9 into I. By using the formula x to the power m plus n, write as x to the power m into x to the power n. I repeat again, x to the power m plus n, write as x to the power m into x to the power n. So we can separate that term, that the value is 1. 1 to the power 9 is 1. 1 into I is I. So we get minus 1 upon I. I again is denominator form. We can multiply with I into I. That's why we are getting minus I upon I square. I square is again is minus 1. So we get minus I upon minus 1. That is the final answer is I. Next example, iota plus 1 upon iota whole to the power 25. So we can write that by expanding it. No formula of power 25. That's why we take their LCM. Now by LCM we get I square plus 1 upon I. I square is minus 1. Minus 1 plus 1 is 0. 0 upon I is 0. 0 to the power something is 0. So the final answer is 0. Next example, 1 plus iota whole to the power minus 2. We can write that 1 upon iota 1 plus iota whole square. And the formula of a plus b whole square, applying it, we get 1 plus I square plus 2i. That is the term. By expanding it, I square is minus 1 plus 1 cancel. We get 1 upon 2i. Now 1 upon 2i, again I in denominator format. We can multiply with I and divide by I. So we get I upon I square. I square is minus 1. That is the answer, minus I by minus 2. It means minus 1 upon 2 into I. That is the final answer. Next example, iota plus iota square plus iota cube plus iota 4 equals to iota I square is minus 1, I cube is minus I, and iota 4 is plus 1. All these terms are cancelled. Minus I plus I, minus 1 plus 1, answer is 0. Same example, we have iota power n, iota the power n plus 1, iota the power n plus 2, iota the power n plus 3. So we can write them iota the power n plus iota n into iota the power 1. Separate the term, separate the power. Again that is iota the power n into I square. Again iota the power n into I cube. Take common iota the power n in all these terms. We get 1 plus I square plus I cube. Same method is we can put that value, that is the least form, that is the form of I square, its value is minus 1, I cube value is minus I. Minus I plus I cancel, minus 1 plus 1 cancel, so we get iota the power n into 0, is their answer is 0. So here we see that if the sum of all 4 consecutive power of an iota, their sum always will be 0. These are the note of that question. Sum of 4 consecutive term of an iota is there will be 0.